What up, Algebra Squad? Welcome to your final lesson from module number 6.5. And this one's titled Systems of Inequalities. Now, you've heard of something similar, which is systems of equations, but this time we have inequalities. I don't know why I just boxed in that part. If I read the whole entire word, I don't know. But what I wanted to do, where my brain was taking me, was equations in the prefix equal, that would be equal sign, right? We're not dealing with equations right now. We're dealing with inequalities. That's when we have the greater than, less than, greater than or equal to, less than or equal to, right? So just look at the little image that we have here on the right-hand side, and it's going to go ahead and remind you a little bit what inequalities are. Inequality means that we're talking about something that's less than, right, or more than. So it's a bunch of numbers. It's greater of a possibility. I don't want to say that my answer is equal to 7, right? That's just one single solution. So a system, don't forget, system stays as the same meaning. System is just more than one inequalities. So as always, what the heck is the solution to a system? Well, the solution to a system is the region that is true for both or however many inequalities you have together. So if you look at the blue and the red right now, what are the solutions for the blue one? Well, the solutions for the blue one, I'm going to go ahead and draw a dot right now. The solution for the blue one is anything inside of this blue region, meaning it can be on the solid line. Remember that if you have a solid line, your points on the solid line are included, and anything in the shaded region. Okay, this is also part of the blue. Okay, but if I go above this blue line, then I will not be at a point that will make the blue inequality true. So if I were to grab this dot right here, which is located at -1, 7, and I grab -1 and 7 and plug it into the equation that made that blue line, then it will not be true. It will give me a false statement because it's not an answer. So same idea with red. Let's say I put a dot right here. This dot is a solution to the red inequality. It's in the red shaded region. It is also anywhere in this red shaded area, right? And it's not only the parts that we can see. We can take this dot up high forever, because this region, shaded region, goes up forever. All right, don't be fooled that the little red stops right here, the red region or the shading of it. Don't be fooled. It goes forever. Now, don't forget that a dotted or a dashed line means that the solution is not part of that line, okay? Because this one would say something like, my answers are everything above this line. Well, this dot is not above that line. This dot is on that line, so it would be incorrect. So if you were to plug in that x comma y of this point right here into the red inequality, it will not give you a true statement. It'll say something like 7 is greater than 7, and that's not true. 7 is not greater than 7. 7 is equal to 7. So with that said, what is the solution to the system? We now have two or more that we have to think about. The solution to the system is the point or points, all right, that satisfy both of them. Together. So my question to you guys right here is this black point right here that I placed on the screen, is it satisfying both of them? The answer is no, it's only satisfying the blue one. What about here? Whoa, here. No, it's only satisfying the red one. What about here? Is it satisfying the blue one? Yes, it's part of the blue region, but is it part of the red one? The answer is no. On the red one, this is on the dotted red line, so it's not part of the red one. So my answers have to be, listen to it out, my answers have to be everywhere here. So I think it's going to be better if where they have the common shading, where they have the common shaded region, but also we are including the solid blue line, because the blue line also tells us that anything on the line is good. Notice that I didn't do anything for the dotted line, because the dotted line, it says that it's not part of the red one. All right, so it's just like that. That's it. That's all there is. We got to find where the two solutions agree. All right, let's go ahead and do example number 1. Solve the system of inequalities by graphing. All right, what do we do to graph? Well, we need to go ahead and put everything in slope-intercept form. Remember that slope-intercept form is y equals mx plus b. I know we're not using equal signs, but we're writing it right now just so we can talk about the form. So if I want to grab x minus 2y is greater than -6, and I want to put it in slope-intercept form, I would have to take the x to the other side. First, I have to move the stuff that is adding or subtracting, and this x is causing that type of operation, the adding or subtracting part. So remember that I want to write my x in front of the -6. I want to write that minus x in front of the -6. So I can put it as much as possible to look like this slope-intercept form here, right? And then lastly, the last thing I'm going to do is I'm going to divide both sides by -2. Remember to not just divide here. Did I say add? I don't know if my brain said add, but I meant divide. So we're dividing both sides by -2. Now, please don't forget, the rules still apply. Right now, we divided by a negative number. Did y'all forget about this? We must flip the sign. So in order for us to have a true inequality, we need to flip the sign. And now we need to go ahead and finish this out. Don't forget that in front of every variable, if you don't see one, there's always a number 1. So think about the number 1/2. A negative divided by a negative is a positive. So I'm going to leave it as a positive fraction. Apply my x right next to it. So it's easier to just look at the 1/2 as my rise over run. And then once again, negative divided by a negative is a positive. And then 6 divided by 2 is 3. I am done graphing. I'm sorry, putting this into slope-intercept form with the red one. This right here is my slope. And this right here is my y-intercept. Don't forget that we always start graphing with our y-intercept. So I will go with the 3. I'm going to go up to 3 in my y-axis. 1, 2, 3 is located right here. And I'm going to put a point. Put a point at the y-axis, sorry. And now follow your staircase, 1/2. Think about it. 1/2 is a positive number. There's no negative in front of it, even though you might have gotten fooled right here at the beginning, but a negative and a negative in division cancel out. So 1/2 means I can go up 1 to the right 2. I can do that. I can go up 1 more and then 2 to the right. I can also reverse that, and I can actually go down to the left 2. Okay, down to the left 2. Don't worry that, oh my God, it's supposed to be either up or no, you can either go up or you can go down. It does not matter. The next question you have to ask yourself is, remember, don't make the line yet. Should I have it dashed or solid? Looking at my symbol right here, this symbol does not have the or equal to little line at the bottom. So we go with dashed, right? Dashed. Bada bing, bada boom. All right. So let me go ahead and create my dashed line. I'll go ahead and fix it in a little bit. Make sure we got 2 arrows on both sides. All right. There we go. We have a dashed line. Now I think about my shading. Where's my shading going to be located? Well, if I look at my slope-intercept form, just the beginning of it, it says y is less than. Now remember that? Y is less than. Just take that. Less than means under, below. Less than is below or under. So that means that our shading is going to happen everywhere below this line, right? Now, please, please, please be careful. Before you're shading, please make sure that you do it very lightly, because this is not, all of that is not going to be our answer. Remember that we still have to graph another one and make sure that we understand where the other one is located. So we don't want to have a whole bunch of dark shading, okay? You have to shade very, very, very lightly. I give you 2 options. You can either use the colored pencils, or you can just shade in different directions with your pencil. You can use very light shading going horizontal for one, and then very light shading going vertical for the other one. And you could see where they cross with those pencil marks, okay? Those are your 2 options I'm giving you. All right, so I'm gonna go ahead and delete this little word that it says flip, and I'm gonna talk about this next equation right here, I'm sorry, inequality. This inequality here is pretty much already in slope-intercept form. Slope-intercept form is y equals mx plus b. Y equals mx plus b. So when we write this down right under it and we ask ourselves, how is this in that form? I'm missing something. Well, you're missing the plus b, right? But you don't always have to have an actual number there. Remember that this is your y-intercept, right? Don't forget that that is your y-intercept. So if there is nothing, just think of the number that represents nothing. What's that number that represents nothing? 0. So if you want to see it as a 0, put it as a 0. That's already pretty much graphable in the graphable format. We go ahead and grab our slope of 3. We got slope, y-intercept of 0. We have another dashed line, dashed. And we have y is less than. right? So we could see that it's shaded below. Everything is right there. Everything is right. Everything is awesome. All right, so let's go ahead and graph this one. Starting at a y-intercept of 0, here it is. Then we have a ladder or a slope of 3. Remember that you were thinking of 3 as 3 over 1, and this is my rise over run, meaning you can either go up 3 to the right one, or you can go down 3 to the left one, whatever's up to whatever you want. But remember that this is a positive number. So 1, 2, 3 to the right one, and I can go up. I don't have enough space to go up anymore, but what I'll do is I'll go 1, 2, 3 to the left one, okay? And I don't have any more space here either. Now, don't worry, we're not looking for where the lines meet, okay? So if you guys are kind of freaked out and wondering, where do these lines meet? That's not what we're looking for. That's only with equations. We're looking for the shaded region. So what we want to do right now is we want to go ahead and create our dashed line. So let me look for my lines right here. Bada boom. Let me put it here. Drag this one out. Nice them both. Got it. Oh, that moved. All right, there we go. So that's my blue one. And it says that the shading has to happen below, because it says dashed. It says y is less than. So I'm shading below this blue one, right? So what I'm going to do is I'm not going to go ahead and care about this other red one. I'm going to go ahead and shade with my blue. Remember, I'm using my smartboard. So be careful with the amount of dark shading that you use. Understand that this is not your solution yet. You need to eyeball it afterwards. So I'm going to go ahead and make this very, very light, like that. Okay. And now I can say, okay, where is my solution located? Where's my solution located? My solution is located right here. Right here. So I'm just going to go ahead and write a little snippet saying solution. And I'm going to put parentheses here because we have infinite amount of points. All the points, every single point that is within this red and blue, where the red and blue shading is happening, that is where my solutions are happening. Solutions are found in the shared, let's go ahead and put shared, shaded region. Whoa, that's not going to be an SH, that's an SO. Shared, shaded region. Okay. And to kind of talk about this a little bit more, remember that both of these lines are dashed. So no point that lands on that line or any of those lines will be your answer. No point on either of these lines are going to be your solution. Okay. Just everything that they have in common and they have shared. All right. And just to kind of make it a little bit easier, if you want, you can do this yourself as well. You can go ahead and erase that part that they don't have in common and make it a little bit more obvious for yourself. All right. Now, you guys know what I always like to do. I always like to put bring out decimals just so we can check our work. I already have everything written exactly how it's given to me. I don't even have to put it in slope intercept form just to make sure that I did it correctly. And here are my two regions. So let's see if it makes sense. The first one that we were looking at had a y-intercept of 3. There you go. And then it had a rise over run of like, what was my rise over run? Of the first one, 1/2. So for the red one, I went up 1 to the right 2, up 1 to the right 2. So it makes sense. Here it is. So this is it. Now remember, I just want to remind you that I can keep zooming out forever. Remember that this shaded region is an endless amount of points that exist in this, well, now purple region, right? The blue part is not a solution part. The red part is not a solution part, but the blue and the red together is where my shared region is located. Cool. All right, that's pretty much it. Let's go ahead and give it a check problem. Go ahead and pause this sucker and try it on your own. Let's do it. All right, Let's go. Hopefully you did not cheat yourself. Let's grab this and put it into slope-intercept form. So right now it's written as 1/3 x plus 2 less than y. What do I notice? I notice this is actually already pretty much in slope-intercept form because y is by itself. Y is already by itself. So what I'll do is this. I'll go ahead and rewrite it where I'll put y here. I'm going to trick my eye. I'm going to put y here. Notice how the symbol is facing is opening up to y. So I'm going to go ahead and open it up to y. And then I'll write 1/3 x. It's positive, right? You see that this is positive. So I'll write it still as a positive. And then I see that it's +2 or a +2. So I'll still write it as +2. There you go. Done. You didn't really have to do anything taking any number to any side. This is already written in slope-intercept form. I could see that my slope is located right here. And my y-intercept is located right here. All right, so we always start with the y-intercept of 2. So let's go up 2 in the y-axis. 1, 2, create your points. I know that my line will be crossing that point right there. And I have the staircase ladder of 1/3, and it's positive. Don't forget that this is positive. So my line has to go up from left to right. So I can go up 1 to the right 3. I don't want to go up to the right 3 because I have no more space. I can go down 1 and then to the left 1, 2, 3. Here it is. I once again have no more space. Here I read that it's y is greater than. Notice that this is dashed. Don't forget that we have a dashed line. And greater means that we have to shade above our dashed line. So let's go ahead and create our dashed line. Yep, that's the sound that a line makes. All right, there we got it. There we go. There we go. There we got it. Shading above. Y is greater than. Shade, shade, shading above. Shade, shade, shading above. Shade, shade, shading above. Shade, shade, shade above. Yeah, aren't you jelly that you can't do what I'm doing with my smartboard? All right, there I have it. I went ahead and put it a little bit lighter. That way I can not have a crazy amount of stuff here when I graph the other one. This is going to be my blue one. Oh, okay. So now we have an x by itself. Okay. Please remember, always guide yourself to this idea. Imagine if you were to write this with an equal sign, like an equation and not an inequality. So what would it mean if you write x is equal to -3, right? What would it look like as a line? Because this is a line. X is equal to -3. If you were to graph it as a line, means that you go to where your x is -3. That's where you go to. X is -3. So 1, 2, 3 to the left. That's -3. And now what you do is think about it. What line can you possibly draw? What line can you possibly draw where x is always -3? Always -3. Well, the line that you can draw would be the line that goes like this. Because if you think about all these points, infinite amount of points, they all have the x value of -3, because this would be 0, -3. This would be, I'm sorry, 3, -3, -0, -3, 1, -3, 2, -3, 3, -3, 4, -3, 5, so on and so forth. So this is the line where you will always have a -3 as your x. Now, this is, let's not forget that this is an inequality. Inequality means we're talking about more than or less than. So how do I read this? My x values, or the solutions that I'm thinking about, have to be greater, more than, right? More than or equal to the number -3. So if you look at this blue line, where are your x numbers that are more than -3? If this is -3, then this would be -2, -1, 0, 1, 2, 3, 4, 5. Think about it, right? That makes sense. All the numbers that are more than -3 are to the right. Whenever you're on a number line, always and forever, the numbers that are greater than are always to the right. So my answer to this will be, and let's not forget, right now I just thought about it, but my line has to be solid, okay? Solid, because of the symbol that we're using. We're using the greater than or equal to, right? So I'm going to go ahead and do my solid line in a little bit. Okay, so let me go ahead and work out my solid line. I'll just do it. It's a nice vertical, so I won't worry about. There we go. And there we have it. It is very clear where my solution is located. Once again, if you want to use your own eraser, I don't have excessive amount of erasers to do this. You can go ahead and clear this area that they don't have in common. Or the more you do this, the more you practice this, you can actually do the shading at the end. Okay, I'll give you that as an option, and then you can just decide and think about where the shading will go. Which one they haven't shared. Here it is. Your solution is located right here. Solution region. And what are great quiz questions? Well, great quiz questions are going to say, well, if I were to draw a dot, say this black dot right here. Actually, let's make it another color so we can see it a little bit better. If I were to draw this yellow dot right here and I was to start moving around and ask you, is this a solution? So my question to you is, if I put it on this x equals -3 line, or I'm sorry, yeah, right now this is just the line. If in this line right here, would it be a solution? The answer would be not to the system. It's only a solution to the inequality where it says x is greater than -3. So as soon as I bring it up here, it is a solution, because not only is it part of the blue one, but it's also part of the red one, because the red one, don't forget that the red one had all of this included as well. Okay, so anything on the solid blue line that's right here, I guess let's do it in yellow so we can have a good vision. Anything on this line and above the dotted line here, that is going to be a shared solution. Done. Good. Simple. All right. You can go ahead and see from the title that we should have no solution in this one, but let's see what it looks like. All right, solve the system of inequalities by graphing. If you want to challenge, pause it right now and try to do it on your own. All right, so let's go ahead and grab this one right here. -3x plus 4y is greater than 0. Let's go ahead and turn this into slope-intercept form. We'll take 3 to the other side, 3x, by adding, because the 3x is a negative. That's addition property of inequality. This right here should be a 4. I don't know what that looks like. And now we have 4y. Keep the symbol the same way. We have not multiplied or divided by negative. 3x is going to go first. And then if you want to look at 0, keep 0. Keep 0. That's fine. If you want to look at 0 because that's your y-intercept at the end, keep it there. Fine. We take 4 by division, but don't forget we have to do it to every single part. Also, don't forget that not only do we not flip the sign here, but separate your 3/4 from your x so you could see it as your slope. And also, any 0 divided by any number stays as a 0. So don't get fooled by this and ruin your work. All right, so we're pretty much done here. We have slope, intercept, everything we needed to right there. Let's go ahead and do this one as well. Just get it out of the way. So we have 3x minus 4y is greater than or equal to 8. We would take the 3x, same idea, but by subtraction this time, because that 3x is positive. That's going to leave us with -4y. Don't forget to bring that negative in front of the term. Here, we're going to keep writing it as -3 plus 8, because those two terms are not like terms. They do not combine. Addition and subtraction, you do not combine like terms that are not alike, unlike terms. Only in multiplication and division are you allowed to simplify. It allows you to simplify, or AKA do something with it. So what happens here? I just wrote something wrong. Here we need to flip, okay? Hopefully somebody caught it. Flip my sign, because I divided by -4. I keep it as now, not keep it, I change it as less than or equal to. A negative divided by a negative is a positive, so my fraction will stay the same here, just positive. And then positive divided by negative is a negative. 8 divided by 4 is 2. All right, so I'm done with this one. Now, let's go ahead and graph the red one. The red one has a y-intercept of 0. So starting at 0 with a ladder, a positive ladder of 3/4. So I can go up 1, 2, 3 to the right, 1, 2, 3, 4. Or I can go down 1, 2, 3 to the left, 1, 2, 3, 4. There it is. Now, the next thing is, it says, greater than. Not only are we shading above, but this is a dotted line, okay? This is a dotted line. So it's going to look like this, or a dashed line, whatever you want to call it. Okay. It passes through these points, dashed line, and greater than meant above. Don't forget that anything on the line will be wrong. It's incorrect. Anything on the line will make the inequality false. any point that you choose, remember a point is an x comma y. So any x comma y that you choose that is on that line will make your inequality incorrect. It'll give you a false statement. All right, let's go to the blue one. The blue one has a y-intercept of -2. So we go down 2 in the y, and then we have a ladder of 3/4. Ooh, 3/4 and 3/4. Same ladder, but different height. Same ladder, but different height. What I talk about height is, remember that your y values are the ones that are up and down, and your -2 right now is located right here. So let's look and see what happens. 1, 2, 3 to the right. 1, 2, 3, 4. 1, 2, 3 down to the left. 1, 2, 3, 4. So what happens here is, whenever you have, and we talked about this, whenever you have the same tilt, the tilt is your slope is your rate of change. The tilt is how much your line is, well, yeah, slope is how much your line tilts. Pretty much they have the same tilt, but a different height, and that is the definition of, that is literally the definition of perpendicular lines. Same tilt, different heights. Because if they have the same height, then that's essentially the same line. Okay, so now here it says, remember that it's solid because of the symbol that I'm using. It has a little or equals to here at the bottom. And then it says y is less than. Less than means below. So look what's happening. My shading for the blue one happens below the line. So for that reason, if you can look at now and ask yourself, where do they share the same shaded region? Well, do they have a shared shaded region? No. The blue has its own shaded region. The red has its own shaded region. They do not intersect at any point. This is no solution. There is no point, no solution. There is no point that is located on both of these. You can either find a point located on the blue one or on the red one, but there's no point that will make both inequalities true. Okay, I just want to remind you. Let's say that I choose the point 1, 1, 2. So this point right here, which is located at 1, 2. If I grab those two numbers, which are indeed in the red shaded region, and I plug that x and y right here, it will give me a true statement. That's going to give me, everything here will give me a number that's greater than 0. It's true because it's in the correct section. But if I grab 1, 2, 3, -1, 3, -1, if I grab this x, y, and I put it in the red one, it's not going to work. But if I put it in the blue one, it will work. That is what it means, that it's a solution for one, but not a solution for the other. And we're looking for a solution for both of them. All right. All right. Pause this sucker and try it out. All right, let's go ahead and check our work. We're going to go ahead and call this the red one. I'll write it as x plus 3 less than y. Once again, this is pretty much already in slope-intercept form. You just got to flip it, where you put y on this side. You put the sign exactly facing the same way that it was facing before. So it's the opening side is to the y, and then I'll write x, and then I'll write +3. So positive x and +3, keeping the same relationship that I had up here. That's a positive x and a +3. So I write it as that. So this is already in slope-intercept form, ready to graph. And then we look at this bottom one, where I'll go ahead and take 3x to the other side by subtracting. That is going to now give me -3y. Don't forget to keep your 3y negative. Sign stays the same. I'll go ahead and write -3x. 12 was positive. Now I'll take the 3, which is negative, to the other side by division and divide everything equally by the same thing. You cannot do something to one side without doing the same thing to the other sides. Here we flip. Be careful. We must flip. We're dividing by that -3. A -3 divided by -3 is a positive, and it's a +1. So it's a 1x, or just x. And then positive divided by negative is negative. 12 divided by -3 is -4. So here is the blue one for us. Let's go ahead and graph the red one. The red one has a y-intercept of 3. So in my y, I'm going to go 1, 2, 3, 3 up. And then my ladder is 1, which is 1 over 1, right? Up 1 to the right 1, up 1 to the right 1, or I can go down and left, down and left, down and left, down and left. What does it say? Well, I have the greater than symbol. The greater than symbol tells me that, or when I read it, it says y is greater than. It tells me that my shading goes above, but I don't have the or equals to. So my symbol, I'm sorry, my line has to be dashed. So here comes a dashed or dotted line, whatever you want to call this. And that, remember, says that nothing on the line will be true for this. Nothing on the line will be true for the inequality. It says everything above greater than. Y is greater than, so we shade above. Click on your shading, make it lighter, bada bing, bada boom. Next line, we have a y-intercept of -4 on our next line here. So 1, 2, 3, 4. And then the ladder is the same ladder. It's a 1 over 1. So it's going to be looking like this. Remember that the ladder is positive. That 1, that x right here is a positive x. So the ladder or the line has to be going upwards. It is it has a solid line because of the symbol that I'm using, the inequality symbol that I'm using. And it says y is less than or equal to. So less than or equal to will be located over here. And this should make sense. We're practicing right now. We're doing the check problem, the practice problem from the previous one that was no solution. So here it is. Once again, look at the idea of the same slope. We have a slope of 1, but we have different heights. Every time you see that, every time that you run into two lines that have the same slope but different y's, that is going to be two parallel lines. All right. That is where we're going to be stopping this video. Good luck. If you have any questions, let me know. Peace out.